All right, here's a cubic one. Can't factor it. We're going to use our calculator. That makes the most sense with this problem. So I'm going to go back up here, clear these out. I want to know where this cubic is greater than 0. I do not want to include the zeros because there is no equal sign. And I'm going to go zoom 6 to make sure I can see all of my graph. And I want those that are greater than 0. Well, it's above the x-axis from here to here, and it's above the axis from here to here. So I need those zeros. I'm going to calculate my zeros. Second, calculate 0. And I'm just going to go left to right. That just makes sure I've got them all. Left, right, enter. So my first 0 is a negative 1.601. Second, calc. And I have to calculate another 0. I have to be left of it. I have to be right of it. And my next 0 is a 0.227. Calculate another 0. Left, right, and I get my last 0 to be 1.373. Now I have to put this in interval notation. I want those that are above the x-axis. So my first option is I'm going to say from negative 1.601 to 0.227, not counting those zeros. That's all these x values between these two that make this curve above 0. The other place that I want is all of these x values. So I want 1.373 to infinity. I do not include infinity because I can never get there, and I do not include these zeros because this is not an equal sign. Now I could factor these just to find out my zeros. This one happens to be factorable. I could get 2x and x, 2x, 3 and 3, 6x. So basically I have 2x plus 3 squared. So this is just going to touch, and it's going to touch at negative 3 halves. I set this equal to 0 and solved for x. So what I have here, if I graph this on my calculator, more than likely 1, 2, so down here it's going to touch and it's going to go up like this. Well, let's look at this. Okay, let's verify that's what it looks like first of all. So I clear this out. 4x squared plus 12x plus 9, zoom 6. All right, I found my 0. Now I could do second, calculate 0. And let's see, I got to go to the left of it. I got to go to the right of it. And it gives me the 0 at negative 1.5. Well, all the x values, that's the only one that makes it equal 0. Everything else makes it above. So if I'm going to put this in interval notation, everything will work, including my 0. So it is all real numbers. All right, this is 71. It's projectile motion. So let's read the problem. It says a projectile is launched straight up from ground level. Ground level tells me the height at time 0 is 0. And it tells me the initial velocity, and this is what I have to read in the problem, happens to be 320 feet per second. And this is feet. So that is the initial part of the problem. Part A says, when will the projectile's height above the ground be? So when is S going to be 1538 feet? Now I'm going to plug it into my formula. You do not have to memorize this formula. It will be given to you. This is going to be y1. This is going to be y2. My x-min represents my time. I never go backwards in time. I do not know how long this will take. I'm going to say 20 seconds. And I'm going to put my x scale I think it's scale, at 1. Now my y-min, I'm going to put it at -5 in case I need to calculate zeros, but I don't have to. I could put it at 0. My y-max, well, I'm looking at 1538, so I'm going to say 2000. And then what I'm going to do is I'm going to put my y-scale at 100, at 100 feet increments. And let's see what this graph looks like. So this is what I have. I'm going to clear this out. I'm going to put 1538 in y1, -16t squared, make it an x, don't make it a t because it doesn't know what that is. You're in function notation. And let's see our windows. I'm going to put 0, 20, scale of 1, -5. I'm going to put 2000, and I'm going to put increments of 100. And let's see if this graphs it. It does. So it's going to be exactly 1530 feet when it's here and here. So in part A, I need to calculate the zero or the intersection. So second, calculate intersect. That's my, I'm going to get closer to this one. That's my first curve. That's my second curve. Yes, I want you to guess. So what I have here is my first intersection point is 8.03 seconds. Let's find the second intersection point. I have to get closer to it. Yep, yes. So my second intersection point is 11.97 seconds. So those aren't nice integers, but that is when it will be exactly 1538 feet. So let me move my calculator out of the way. Part B says, when will it be at most 1538? So let's look at this again. At most means my maximum is 1538. So it's anywhere from 0 to this intersection point. And it's anywhere from this intersection point to when it hits the ground. So I need to find out when it hits the ground. That's calculating a 0. Second, calc 0. And if I go down, oops, other curve, go down here to my left of it. Okay, enter. Now I can't really see, but do you see this point here? This is above the x-axis. So I am going to keep going until my x is negative, or my y is negative rather. That's not doing it. Let's see. I'll hit enter and we'll guess it. So this end point, it hits the ground at 20 seconds. So what I have here is it's going to be at most from 0 to 8.03 seconds, or from 11.97 seconds to 20 seconds. That's when it's going to be at most 1538 feet. Part C says, when will it be greater than or equal? So greater than or equal, let's look again. It can equal 1538, and all along here is it's above. So what we would say here is that that's between 8.03 seconds and 11.97 seconds. You will have a projectile motion. The equation will be given. Notice the hardest part is putting in your window and finding those intersection points. The last two parts were just reading it and finding those intervals. All right, 72 is a jet airline that takes off at this slope. And it wants to know how far do we have to go horizontally so that this plane can go up vertically 20,000 feet. Now, big deal. Why would we want to know this horizontal distance? Well, you want to make sure any plane that lands at your airport or takes off at your airport has a long enough runway so that if I want this plane to go up 20,000 feet, I need to make sure I have a long enough runway at this slope to be able to rise 20,000 feet. So it's important in designs. There are airports where certain planes cannot land on them. I did read that in higher altitude airports, because of the air pressure, they have to have longer runways. So it would be very important that they design them properly. So remember, the slope we're going to assume is constant. So we want to know this horizontal distance. We're going to call this 0, 0. So we know that 4/9 equals, and up here this point is going to be, we don't know what the x is, but we're looking at 20,000 feet. Since the slope is constant everywhere, we're going to take 20,000 minus 0, x minus 0. Since I can ignore these, I now can cross multiply 2, 3, 4, and solve for x. So if I take my calculator, let's see, 9 times 20,000 should be 180,000 divided by 4. I'm going to need 45,000 feet of a runway for this plane to take off. And each plane size will require different runways.